Okay, so yesterday we had, kind of talked about try and sum. So if we focus on the problems that were highlighted, especially like 7 through 22, let's talk about those first. Were there any problems 7 through 22 that you still had questions on? Yes, 11. Okay, let's talk about 11 real quick. Because there is a square in the bottom, my suggestion would be for 11 is to square both of those pieces first. So 2 squared is 4, x squared is x squared. Then you're going to want to reduce as much as possible. 8 is divisible by 4, so you can divide and get 2. Sometimes you might want to write 2 over 1 because you may need that 1 in the denominator. It's not necessary in this particular one because x squared does go into x cubed and leaves 1x behind. Okay. Any other questions? We're still just talking about 7 to 22. Yes. Yes. Okay. So 15, you're just going to square root the top individually, square root the bottom. Now, it's always a good idea to look, could you reduce that fraction to begin with? In this particular one, we can't reduce the fraction, so just leave it. But we can individually do those square roots. The square root of 9 is 3, but the x, I can't take the square root, so just leave it. The square root of 16 is 4. So the answer there would be 3x over 4. We started 16 a little bit yesterday, but let me show you what your final answer would be. You would distribute the 11b on top. You would get 11b minus 11b. Just set that in front of the square root of b. And then on the bottom, when you go to FOIL that, remember, you're going to be distributing. You should get, because it ends up being the difference of squares, you get 1 minus b. Now, we did that conjugate multiplication. Our goal was specifically to get rid of the square root in our denominator, and that's exactly what happened. Okay, and then 17, we did that one yesterday, so that one's there. And then now let's focus on 18. Remember, a cubed root and a fourth root is asking you what number cubed gives me that. So, numbers cubed, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. There's a very limited number of numbers to look for. 625 is 5 to the fourth. So that fourth power and that 5 will cancel each other out. Lovely. And so remember, a negative under an index that is odd is perfectly okay, because negative 2 times negative 2 times negative 2 is a negative 8. So negatives underneath an index that's odd is fine. Remember, negatives under like a square root, you got to worry about like that I and things. We'll deal with that later. And then 625, since this is 5 to the fourth, this just becomes 5. If after you've done each individual one, there's a way to reduce the fraction, reduce it. This one's fine the way that it is. So any questions now about the radical section? Are we okay there? Okay. I think for 19 through 22, you probably got those okay, I would assume. I want to take the time to focus on 23 through 26. Okay. 23, the formula that you want to use, I think I had given it. Didn't I give it to you yesterday? Did you see that formula yesterday? If I didn't, here's the formula. That's the difference of squared, a squared minus b squared, which can factor to be a plus b, a minus b. So when we do the formula for 23, just think of that as what was squared. Well, 4x was squared and 9 was squared. So in the formula, we're going to replace a with 4x. We're going to replace b with 9. And so if you discover what's being squared, if you do that little thought process, I think it would help your brain go through that. So if we replace a with 4x, we get 4x. B is 9, so that's plus 9. And 4x minus 9. It's not a bad idea to get in the habit if the parenthesis can factor any further factor it. There's no reason to, there's nothing in common, there's nothing you can do. That is your final answer. Now, I know I'll give you the answer to 24, but since it's so much like the ones we did yesterday, let's jump for now to 25, because it uses the formula a cubed minus b cubed. Now, how do I know that? Well, the fact that c is a 3 or a power of 3 is very helpful to determine that that's the thing you want to go with. But 27 is 3 to the third. 1331 is 11 to the third. So in this formula, our a is going to be replaced with a 3c, our b is going to be replaced with an 11. And the formula is a minus b times a squared plus ab plus b squared. Now, what's kind of interesting about that formula is that formula does work if there's a plus here. You can't do the sum of squares, but you can do the sum of cubes. And all you do is, this is always the same as the sign in the original. This is always different. This is always positive. So there you got a formula to use. So if we use the one in pink, our answer is going to be 3c minus 11. Now when you square 3c, square all the pieces, so that would be 9c squared. Plus ab means that we are going to multiply a and b. So if we multiply a and b, 3c times 11 is 33c, and then 11 squared is 121. So that's the formula. We'll revisit that formula when we need it again at future reference, but just so you know how that formula works. Okay. Now let's jump back to 24. That is just y plus 6 times y plus 6. Feel free to write that as y plus 6 squared. That's okay. The one I think that's really funky is 26, so let's talk about it. In calculus, there is a technique, a formula for taking something called a derivative of a fraction. It's called the quotient rule. And when you do the quotient rule in calculus, the numerator of your fraction can sometimes look like this. So they're just introducing you to some funky things that can happen in a calculus class. This is pre-calculus, So to do that, think about when we factor a greatest common factor, we remove the lowest power. So the lowest power between negative 1/4 and positive 3/4, what's the lowest number there? Negative 1/4. So the interesting thing is we are going to remove a negative 1/4. Now factoring is division. That's okay. So when you factor something out, the division process, you subtract the exponent. So if we're going to subtract a negative, what happens to the sign? When you subtract a negative, it becomes a positive. So technically, we're going to add 1/4 to this power and this power. It's kind of funky. And it's introduced to you now just because it can happen if you take calculus. Okay. So what do you get? Well, you get 3x because you already took out the negative 1/4. We have to add 1/4 to this. 1/4 plus 3/4 is what? What's 1/4 plus 3/4? 1. So you get one of these. Do you write the 1 when you have a 1 power? Not usually. So something really nice happened. By removing the negative 1/4, each one of those powers went up by 1/4. And so then this can become something nice. This is just 3x plus 2x minus 12. For a final answer, when simplified, of x minus 6 to the negative 1/4 and 5x minus 12. Now again, that is not a type of problem we will see very often. If you grasped a little bit about what it looked like, that's the kind of stuff that you would see possibly in a calculus class. Weird algebra sometimes happens. Okay, so that is the factoring portion. We're going to do 27, 28, and 29, and then you have till midnight tonight to get this assignment turned in. Okay. Okay, so let's do 27, 28, 29. I'm going to take you through that, and we'll see what happens. Okay. If you see a fraction that has polynomials in the numerators and denominators, you always want to get it into factor form first before you proceed. So let's deal with the bottoms first. We've seen some formulas to deal with difference of squares. This one would be z plus 3 and z minus 3. This one would be 2z plus 1 and 2z minus 1. So I would assume those two factorizations should start to click again in your head. You've seen these types of stuff before, okay? The ones that I think are a little funky are the top of these. We're going to factor those. And when we factor those, you may have learned back at your homeschool, like I know Lakeview uses asterisk method. Different schools might teach it a different way, but it ends up essentially being the same thing. I don't teach the asterisk method. I like a method called slide and divide. Now, I taught Algebra 2 for at least a dozen years, 5 periods a day for 12 years. And so I've seen lots of ways that factoring is presented to students. And this to me is the most consistent, the easiest to work with. So I'm going to teach you slide and divide. But if you already know a method you like and you're getting it, do it. I don't care. Okay, that being said, let's factor 2z squared plus 7z. I always want to start making a z. Plus 7z plus 3. Now, I use a method called slide and divide. So we're going to take the front coefficient in descending order. We're going to slide it over, and we're going to multiply it by what is on the back end. So plus 3 becomes a plus 6. So we're going to multiply. And then, so the slide over, multiply. And then we just factor it the way we know how to factor these. What factors of 6 will add up to 7? And it's just going to be z plus 6 and z plus 1. So now, so you slide it over, you do the math, and now it's called slide and divide for a reason. The last step is, and you do the same thing in the asterisk method. You put it, you remember, you make it a fraction. It's the same thing. What do we slide over? We slid over a 2, so now we have to divide by 2. Now, if it's divisible by 2, just do it. If it's not divisible by 2, make sure that fraction is reduced as much as possible. And when it is reduced as much as possible, take your denominator and stick it on the z. So we get 2z plus 1. That's slide and divide. I think it's just so consistent, quick, easy. It makes sense. All the other methods are kind of somehow related to what I just did. But if you like your method, you know how to factor, and you got the same answer I got, do what you got to do. Yes. That's okay. Let me show you. Okay, let me just show you one more time. We slid over the 2, did the factorization, and then we have to do the divide part. So whatever you slid over, in this case a 2, we're going to put it over each of these. If it divides, do it. If it doesn't, whatever fraction remains, the denominator gets stuck on your variable. Okay, so there you go. Now, I'm not going to take the time to do this, but you can check your work. This one factors to be 4z minus 3 and z minus 3. Okay, so remember I said when you have fractions like this that contain polynomials, get them into factored form. We have now done that. And now that we have done that, start canceling. If it's multiplication, you can cancel anything on top that matches anything on the bottom in any location. Yes. Uh-huh. You can 2z plus 1 or 2z minus 1 and z minus 9 doesn't add up to the 15 in the center. That's why slide and divide becomes so helpful, because it only gives you one thing you're looking for. You're looking for that 15. So slide it over, break it apart, get 15. Okay, so now let's start canceling out. I see a z plus 3 and a z plus 3. What else do you guys see that can cancel? Yeah, yeah. Do we have anything else left? Oh, yes, we do. What? I didn't write it down right. Oh, I thought some of you were giving me looks like, I think, Mrs. Hachi, you've lost your mind, and I have. That's a 2. Wait, let's make sure. Z plus 3, 2z plus 1. Yay. Oh, I'm so sorry. Okay, anyway. Okay, so we actually have one more thing that can reduce. 2z plus 1 and 2z plus 1. So then our final answer on top is 4z minus 3. On the bottom is 2z minus 1. We can only cancel anything across the top with anything across the bottom in either fraction if it's a multiplication symbol. If it's a division symbol, remember you got to flip that fraction and then you can do that. Okay. Yes?
Do you do the same signs or the opposite signs?
For which piece?
For doing the top and bottom.
Same. It has to be a perfect match. Perfect match. Okay. So this is what I canceled. So you can see. I canceled those two. I canceled those two. I canceled these two. And then this is what I'm left with. Okay. Everybody good? Okay. Let's look at 28. For 28, the problem is that they want us to simplify, and if you have two fractions, the only way to simplify them when they're adding or subtracting is to combine them by getting a common denominator. So this one needs an x on top and bottom. This one needs a y on top and bottom. So you get x squared over xy, 2y over xy, and then to add fractions, keep the bottom, add or subtract the top. So that's simplified as much as possible. You can't do much else. You cannot do much else. Everybody good with what I did for 28? Okay, now let's jump over to 29. Now, let me first tell you a formula that I'm going to use. If I have a fraction over a fraction, that's called a complex fraction, I'm going to do a technique called big C over little c. And what it is that the outer two that are connected by the big C multiply and go on top. The inner two, which come from the little c, connect and multiply and go on the bottom. Now, another way to think of it, it's technically just this fraction divided by this fraction. And how do you divide fractions? You flip over this one. Look at what happened. That one flipped over. Okay, so it's just a quicker technique. Instead of writing this and then the division sign and then this and then actually flipping it over, you can just jump right to that. So big C over little c, nice thing. I'll use it quite often as we go through the course. So I like to just show it to you right off the bat. Okay, so looking at what we did for 28, let's peek back at 28. For 28, this was simplified because we mushed the fractions together. This bottom two, it's already mushed. So let's leave the bottom two alone, put parentheses there, okay? So I'm going to leave the bottom. There's nothing else I can do. There's no common factors. There's nothing I can do. But the top, I do have to do a similar idea because big C over little c only works if it's a fraction over a fraction. It can't be pieces and parts. So for let's do exactly what we did. We're going to ignore this doesn't exist. We're just focusing on this, and we're going to do exactly what we did for that, okay? So this one needs a 9a on top and bottom. This one needs a 2b on top and bottom. For a final answer, The bottom's going to be 18ab. The top is going to be 9a squared minus 4b squared. Okay. Now, anything that has pluses or minuses, put in parentheses, and let's do big C over little c. Okay. Now, if we do big C over little c, on top, we're going to get 9a squared minus 4b squared times 6a. So let's put the 6a in front. Multiplication is commutative, write it in any order you want. And then we're going to get 18ab times 3a minus 2b. Now, technically, it's a lot like the very first one we did from this section. It's a fraction multiplication, kind of. So remember what the first thing we did, we got it in factored form. This piece right here is not in factored form. So before I proceed further, let's factor that so then we can see, can I cancel stuff? So I get 6a, this is a difference of squares. I get 3a minus 2b, 3a plus 2b. And just like the very first problem we did in this section, we can now cancel out stuff on the top and stuff on the bottom. This is a perfect match with that. Cancel it out. If I cancel out 6 here, 6 goes into 18, leaving me a 3 in my denominator. And then the A's are perfect matches. So then we're ready. Our answer, only thing left on top is a 3a plus 2b. The only thing left in the bottom is a 3b. Now don't try to cancel the 3's out. Nope. Don't try to cancel the b's out. Nope. The 3b is divided into both pieces. So if you wanted to write it under both pieces, that is acceptable, but nothing else is acceptable. Okay? Okay. So that being said, we've done some of the harder ones. This is due by midnight tonight, so if there's any ones you haven't finished, try to finish them up by midnight tonight. If you're finished now, turn it in. Are there any other ones you had questions about? Yes. Yeah. So let's take a look, glance at your page, just see, are there any other ones that you had questions about before we leave this page? Yes.
We didn't cross out 3 and 4. Are we doing those ones too?
Yeah, let's talk about those ones. So I had a question about 3 and 4. Did you get that? Are you done? Did you get that copy down, this one? Okay, what you confused about on 29 before we go up?
So I got the first part where we did the top.
Uh-huh.
And then I got a little lost after that.
Okay, so let me just break down the steps. So I combined these two and got that. And then I did big C, that's the top, over little c, that's the bottom.
Why didn't we do that in the beginning?
Because these were not one fraction yet.
Okay, so the bottom was 1 fraction.
Correct. So the bottom was already something over something. And so that's what I needed to achieve first. You can't use big C over little c until it's a fraction over a fraction. So if there's pluses or minuses and you haven't combined them, you have to do like what we did in 27. You got to combine those fractions. Does that help? And then I did big C over little c, but this piece needed factoring. So I factored it and then cancel stuff out. So 3a squared minus 4b becomes 3a minus 2b and 3a plus 2b, and the 3a minus 2b's cancel then. 6 went into 18 3 times, The A's cancel. So we're only left with a 3b in the bottom and a 3a plus 2b in the top. You can only cancel perfect matching factors in top and bottom. Okay. So now there was a question about 3 and 4. Do please try these. These are just equations. Don't make them harder than you think. This one, do 2x plus 6 minus 12 equals 18. Get the numbers to one side, the x's to the other. There's usually a coefficient on the x to divide off. Just an equation. Don't make it harder. Same thing with 4. It looks kind of gross right now, but it's not. It's not a super crazy thing. 3 plus 3 is 6. Square that, get 36. You get 36y minus 26 equals 10. Same thing. Get the numbers to one side, the y's on the other side. If there's still a coefficient on your y, divide it off. Okay. So your job is to finish this up and turn it in by midnight tonight. At least that's our hope. If you get stuck on anything, feel free to send me a remind message or an email. So if you're done, turn it in. If not, get it finished. Okay. Now, let's talk about Alex real quick before because I would like the students at home from the storm last night to get some information. Okay, so Alex, some of you just logged in. Some of you just got started. If you can try to do the knowledge check, if you could try to get an hour's worth of time logged in, that's great. But everybody's going to get their credit for Alex this week. Excuse me. Next week, the goal every week is to get 80% of your assignment pie done and to get an hour's worth of Alex in. That's a week by week. That's your goal. So some of you will, get through that percentage very quickly. Some of you just chug through that as much as you can, okay? And then there is one other thing. I apologize for all these different apps and things we're using, but the school is requiring that you use Achieve. Achieve, remember, is a program about a reading program to help you become better readers. If you go in and log into Achieve, you only have to do one for me in a month's time, just one. And then you get credit, so some points for doing that. If you are a CCP student, besides the one for me, overall, in all of your classes and day, you'll need to do a total of 6 per month until you reach your Lexile number level set. Like I think it's college readiness. If you've met that college readiness, then you only, and then the Alex, do what you can this week. Okay, so there you go.